10 questions that need to be looked at. We have to answer all of them. So there's a special answer book, but it's not a big deal, that one. We shall see what we can do. Okay, so question number 1. They're telling us that the data below shows the marks of out of 100 obtained by 16 learners in the maths test. And then they want us to calculate the mean mark for the test. So this is straightforward. We just need to get our calculators and do the right thing in the correct mode and get the answer straight away. So the answer I've got for my mean, is 61.38. I'm gonna round off just 2 decimal places. Then my standard deviation that I'm having after punching all this information in the calculator is 19.63. Then 1.1.3, they want us to get the number of learners whose marks are outside 1 standard deviation of the mean. So what this means is that we need to determine the interval for within and outside, which can be obtained by getting the mean. We subtract the standard deviation, that will be the lower limit, and then the mean plus the standard deviation, that is going to be the upper limit. So if I get my 61.38, I subtract the 19.63, and then 61.38 plus the 19.63. I'm going to get an interval of 41.75, and then I'll end up with an interval of 81. So what this means is that I need to find out how many learners got marks below 41.5 and then how many learners got marks above 81, because it's 0.005. Okay, below 41, I'm having a 26, I'm having a 38, and I'm having a 32. So it's 3 learners below. And then above 81, I have the 94, I have the 83, and then I have the 92. So those are 3 also. So in total, I have 6 learners. So that's how 1.1.3 should be worked out. And then 1.2, the 16 learners referred to wrote the second test, which was test 2, and then the information was represented in a box and whisker to show the distribution. Okay, so test 1 is being represented using the first box and whisker, then test 2 is by the second. Describe the skewness for test 1. So when you talk about the skewness, we can see that the mean is next to the Q3. It's closer to the Q3 than the Q1. Okay, so in this case, the skewness is to the left. So we can say skewed to the left. Or alternatively, we can just say it's negatively skewed. Okay, the marks are negatively skewed. All right, then 1.2.2, which test was easier? Okay, so we can see that in as much as this data for the first test is skewed to the left, let's just do the interpretation that Q1 represents 25%, Q2 represents 50%, and then 75%. So I'm going to use the median, which is a 50%. We can see that 50% of the learners got above 62 for test 1. Okay, and 50% got below, so which means 8 learners got more than 62 marks. And then when I look at test 2, 8 learners got more than 66, either 66 or more than 66 of the marks. So the fact that more learners are getting higher marks in test 2, then we can draw a conclusion and say that test 2 was easier. Okay, reason is going to be 50% of the learners. Okay, 50% of the learners got 66 or higher. They got 66 or higher. This is 66%. Same happens to the last one. Okay, we can look at this. This is 25% of the learners. They have 75 marks or above. Here, the last 25% is having 84 and above, which is still the easier test. I mean, for something to be easy, most of the people should be able to get a lot of marks. Then 1.2.3, how many learners scored more than 84% in the second test? So where's the 84? 84 is at Q3, okay? Since they're talking about more than 84, which means it's the Q3 and above, okay? Which represents a percentage of 25%. So I'll just say 25 over 100 multiplied by 16. This should give me 4 learners. Okay, so 4 learners got above 84. Okay, scored 84 or above. Okay, so that is question number 1. Question number 2. Question number 2 is fine. It's not that clear, but I'll deal with it. Okay. So in the survey group of people, we asked about the total distance they traveled from their homes in the last week of December of 2023. Data collected is represented in the table. Okay, there we go. And then the question 2.1.1. How many people participated in the survey? The question told us, no? Did they? No, they didn't. But when I look at the cumulative frequency, okay, the distance, the total distance traveled, or the last distance was 400. If I look at the question paper, it's a 400. And then this 400 is plotted against the 400. So remember, with the cumulative frequency, the last cumulative that you have will represent the total number of people. So I'm going to say that's 400. Then 2.1.2. Determine the values of A and B. So A, remember when you're plotting a cumulative, we use the upper class intervals. So 100 goes with a 20, which is there. And then 150 will go with a 30, which is somewhere there. So that when you add 20 plus 30, you get a 50. So that's why we have this 50 there. So what's going to happen is that for me to get these frequencies, like maybe to find the value of A, I need to find, let me write this as a 20, this is as 50. Then for me to get this, I need to find the cumulative at 200. So at 200, I'm seeing the cumulative to be 100. Okay, 200 goes with 100. So if the cumulative here is 100, I have to just subtract these two. So 50 and 100 subtracted, I'm gonna get A as my 50. Same story will happen with a B. B is at 250. The cumulative at 250 is 200. Okay, so the difference between the two, they told me this is 200. The difference between 100 and 200 will give me my B, which is 100. So that is how we obtain that. And then 2.1.3, 2.1.3, they want us to determine, they want us to estimate the number of people who traveled between 100 and 300 kilometers. So let me do this with this. I can use my ogive to determine that, or I can just complete this cumulative. Okay, so for 300, I'm seeing that's 280, and then this is 350, and then I'm having a 400. So when they talk about 100 kilometers and 300, so which means we're starting from here They said up to 300, up to somewhere there, the interval in between. Okay, so if we do the subtraction, what's going to happen? Oh, we can probably look at it this way, that at 100 the cumulative was a 20. Okay, and then at 300, what is our cumulative? It is round about a 280 somewhere there. Okay, the 280. Then I just need to subtract these two. So I'll have my 280 minus 20, and then I end up with 260 learners or 260 people. And then 2.1.4, if all the people who traveled more than 350 kilometers were removed from the survey, how will this affect the median? It's 1 mark. Now, median is a measure of central tendency. Okay. Now, let's take the people that traveled 350 and above to be outliers. Outliers do not affect the median. Removing any piece of data in most cases has nothing or no effect on the median, but it would affect the mean and probably the mode. Okay, so let's see. Let's just test this and see that if the people that traveled more than 350, so if we take this 50 away, which means our total is now gonna rest at 350. And what is a half of 350? That's gonna give me 175. So if I'm to locate 175, it would be somewhere there, which means my median would be round about that point. Then initially it was a 400, and a half of 400 is 200, which probably means that the median is round about 250. So the question is asking, if all the people who traveled more than 350 were removed from the survey, how would this affect the median? So the median would reduce. Okay, then 2.2, if the estimated mean of this data is given as 16,4, what is the value of t? So how do we determine the estimated mean? Remember, it's the summation of f of x over summation of f. So it's like you get the midpoint of these class intervals. So between 0 and 10, the midpoint is 5. That's going to be 15. It's going to be 25. And it's going to be 35. Then if we can multiply this x and the frequency, and then divide by the total frequency, then we shall be able to get our estimated mean. So I know that 13 plus 12 is 25 plus 4, which is a 29. So my total of the frequency is going to be 29, but plus a t. And then summation of fx, I'm going to have 13 times 5 plus the 15 times t plus the 25 times 12 plus the 35 times 4. Okay, and then I'm dividing this by the total of 29 plus t. This must be equated to 16,4. Okay, so I'll still have 16,4 is equal to the total I'm having is 505 plus 15t. I can multiply this side by the 29 plus t, so that I have a 29 plus t. I'll open this up. I'll have a 475,6 plus a 16,40 is equal to 505 plus 15t. I'll do the transposing. I have my 1,64. If I bring the 15 this side, I get 1, no, it's 1,4. Not 1,64. It's 1,40 is equal to 29,4. Divide both sides by 1,4, t becomes a 21. So that's how the 4 marks would be obtained. So that is question number 2. Question number 3. In the diagram below, the equation of the line AD is given as this. Let me just rewrite this. So that is negative x over 2 plus 11 over 2. M is a midpoint of that line. Okay, the angles of inclination of AD and that are alpha and beta. E and F are the y-intercepts. All right. Okay, so that is the drawing. Then first question, they want us to get the coordinates of A and B. So you can use the midpoint formula. This is 3.1.1, whereby if I get A plus 3 divided by 2 must give me a 1. When I cross multiply, A plus 3 gives me a 2, which means A is negative 1, which is all right. And then B plus 4 divided by 2 must give me negative 1. Cross multiply, B plus 4 gives us negative 2. B is a negative 6. So the coordinates are negative 1 and negative 6. All right, then 3.2. So 3.2, they want us to get the gradient of BC. So with the gradient, we know that is the change in y over the change in x. Okay, I can just use C and M. So I can say 4 minus 1 over 3 minus 1, which gives me 5 over 2. 3.3, they want the theta to 1 decimal place. So for me to get theta, I can find the alpha and also determine the beta. So that my theta is going to be the same as alpha minus beta. But now, since we know the gradient of BC, which means we can determine our beta. So I'm going to say beta is the arctan of 5 over 2. Okay, let's see, shift tan of 5 over 2. That gives me 68,2. Then I need to find the alpha. With the alpha, I already know the equation of AD, which is this. And I've obtained the gradient to be negative 1/2. So I'm going to say the shift tan of negative 1/2. And then I have to plus 180 since it's the negative angle. So shift tan of negative 1/2. I'm getting negative 26,57. And then when I plus the 180, I end up with 153,4 degrees. So I have beta, I have theta, I have alpha. So which means my theta is 153,4 minus 68,2. Okay, that gives me 85,2 degrees. 153,4 minus 68,2. 85,2 degrees. Perfect. Then we move on. They want the equation of the line BC. So since we already have the gradient as 5 over 2, then we can determine the equation. So I'm going to say y minus y1 is equal to m into x minus x1. I'm going to use 1 and negative 1. So it's a y minus minus, which is a plus 1, is equal to m, which is 5 over 2 into x minus 1. Open that up and transpose. So that's going to be a 5 over 2x minus 5 over 2 minus 1. Okay. So the equation becomes 5 over 2x minus 7 over 2. Oh, it's 2,5x minus 3,5. So that is 3.4. Now 3.5, they want us to determine the area of CEF. Okay. So the area of this triangle here. So what I'm going to do, since this is a triangle and I can just use a half base height. So let me take this to be my base. And then if I drop, or if I do that, so that this is perpendicular, this distance here is 3 units. That's going to be my height. And this is going to be my base. Now from the equation that I just calculated, I'm seeing my y to be a 7 over 2 negative. But what is E from this equation? E is 11 over 2. So which means my base is going to be 11 over 2 plus 7 over 2. Okay, so 11 over 2 plus 7 over 2, that gives me 9 units. We're saying the height is 3, so the area is going to be a half base height, which is a half times 9 times 3. So that is 27 divided by 2. I get 13,5 units squared. Okay, so remember, we agreed that our base is going to be EF. So you can also write it as a half times EF, then multiplied by the height, which is now the 3. Okay, so that is 3.5. That is how question 3 would have been approached. All right, then question number 4. Question number 4. Diagram below shows a circle with center P, and the equation is given as such. The circle cuts the y-axis at R and S. RT is a tangent to the circle and cuts the x-axis at T, and then there's an angle theta as indicated. They want us to determine the coordinates of P as well as the radius. So what happens here is that we need to complete the squares. Okay, so I'll just open my 2 brackets is equal to 12. That's going to be x, that's y. So a half of negative 6 is negative 3. And then I must plus 3 squared. Okay, which gives me a 9. Then half of negative 4 is negative 2. So I must plus a 4 since it is 2 squared. Okay, so this is going to be the same as x minus 3 squared plus y minus 2 squared is equal to 25. So this means that P is a 3 and a 2, and then the radius is 5 units. So that's what was needed with 4.1. Then 4.2, can we show that R is 0 and 6? So we know that R is the y-intercept. So I can just get this equation. Okay, where there is x, I replace a 0. So I'm only going to be left with y squared minus 4y is equal to 12. Then I can transpose this. Y squared minus 4y minus 12 is 0. The two numbers are going to be, which factors are those? I think it's 6 and 2. 6 and 2. I'll make this a negative and a positive. Okay, so y is a 6 or y is negative 2. Okay, But we know that r is on the positive y. Therefore, r is going to be 0 and 6. Okay, then 4.3, they want the equation of the tangent. Now, when you're determining the equation of the tangent, if I draw a radius here, okay, we say this is a 3 and a 2. Now we've obtained this to be a 0 and 6. What I need to know is that the radius and the tangent are always perpendicular. And if that is true, I'll need to find the gradient of this radius, and then concurrently I'll get the gradient of the tangent. Okay, so I'll say gradient of the radius, you say change in y over change in x. So 6 minus 2 over 0 minus 3, which gives me 4 over 3 negative. And then the gradient of the tangent is going to be positive 3 over 4, because I know that gradient 1 times gradient 2 must give us negative 1, since the lines are perpendicular. Having obtained this as our gradient, we already know the y-intercept to be 6. So y is going to be 3 over 4x plus a 6. So that's how I'm getting that equation of mine. Okay. Then they want us to get theta. Now theta, how do we get theta? So what I can see is that, how am I going to approach this? Let me look at this theta as an exterior angle to this angle, which is a 90, we know this, and then this angle here, which I can call alpha. Okay, PTO. We need to get this angle first, and then we add the 90, then we have our theta. So since I have the gradient of this line, which is 3 over 4, I can start by finding the angle alpha. Okay, so I'm saying alpha will be the arctan of 3 over 4. Okay, shift tan of 3 over 4 is giving me 36,87. Now I just need to get the alpha plus the 90, which gives us the theta, because that is an exterior angle of a triangle. So which means it's 36,87 plus a 90. And that gives us 126,87 degrees. All right, so that is answered. Said it's 126,87. Then 4.5, they're telling us there's a vertical line that is drawn to the circle at Q, where a is greater than 0. Write down the coordinates of Q. Now, if it's a vertical line, which means it needs to be parallel to the y-axis. And if that line is indeed a tangent, which means it must touch the circle at one point. And this can only happen if we have this kind of thing. So I know that the distance from there up to there is 5 units, since the radius is 5. Okay. Now, if the x is 3 here, what is 3 plus 5? It's going to be 8. And then the y will be maintained as a 2. So the coordinates there are going to be 8 and 2. All right, then question 4.6. I've been asked, like, for which values of k will this equation be a secant to the circle? So currently it's a tangent. For it to be a secant, it must be cutting the circle at 2 points. Okay, with a tangent, it cuts the circle at 1 point. So the values have to be below 6. Okay, but then what if this line is shifted some number of units so that it is in this sort of direction? what will be the y value here, because that's what we also need to know. Okay, so what I'm going to do, if this was my 3 and 2, this is my 0 and 6. Let me just extend this to this point. Okay, so that I have like 2 tangents that are parallel. Okay, so if I call this x and y, I'll have x plus 0 over 2 must give us that, which means x must be a 6 here. And then y plus 6 divided by 2 must give us a 2. When you cross multiply, y is a negative. Is it a negative 4? No, that's a 4 minus 6, which is a negative 2. Okay, so I have 3, then I have negative 2 for these 2 points. Okay, 3 and negative 2. Now let me try to get the equation, but with the same gradient, which is 3 over 4. So we're saying it's 3 and negative 2. Okay, I'm having 3 and negative 2 with a gradient of 3 over 4. So I'm going to say y minus minus 2 is equal to 3 over 4 into x minus 3. Then y plus 2 is equal to 3 over 4x minus 9 over 4. Move the 2 that side. It's 3 over 4x minus 9 over 4 minus 2, which is like 17 over 4. 3 over 4x minus 17 over 4. Let's just confirm that. Wait a minute, we said 9 over 4 plus a 2, 17 over 4. All right, perfect. So which means that this is a negative 17 over 4. Now, for as long as, remember, this k is a y-intercept, for which values of the y must that be a second? So if it has exactly negative 17 over 4, it's a tangent. If it has exactly 6, it's also a tangent. So I'm going to say negative 17 over 4 must be less k, and then must also be less than 6. So in between these values, this line will be a secant. All right. Then 4.7, another circle M with this equation is drawn. Will the circle touch, cut? Will it touch or cut, or will it neither touch nor cut P? Okay. So for the 2 circles, I know that originally with the equation that we had a 3, 2 as the center coordinates. Now here we're having negative 3 and negative 2. Okay, if we obtain them from there. And then the radius originally, radius of P was 5. Now radius of M is a 6. So I'll start by getting the sum of the radii, which is 5 plus 6, which gives me 11. Okay, and let me also get the distance PM using my distance formula. So I can say 3 minus minus 3 squared plus 2 minus minus 2 squared. Okay, distance formula, x minus x1 squared plus y minus y1 squared. Okay, when you do the substitution, that's gonna be a 6 squared plus a 4 squared. 6 squared plus 4 squared, I'm getting 2 root 13. Let's just confirm that 6 squared plus 4 squared is 52, which is 2 root 13. Now, remember, if the 2 circles are touching, the distance we got here should be the same as this distance. Okay, that's if they are touching at one point. Both circles are tangents. Okay, now Let me call this scenario number 1. Then scenario number 2. What if we have this kind of case? This is a P, this is M. We expect the distance PM to be bigger. Okay, distance PM must be bigger than the radius of that and then radius of that. This is 11. 2 root 13 is the same as 7,21. Okay, so we're seeing that the distance in between is bigger. Now the other scenario that we have where the circles are touching is whereby the distance PM is smaller than RP plus RM. So now with the scenario that we have, we're having PM to be smaller. Okay, so our PM is smaller compared to the total distance. So what's going to happen? We're going to draw a conclusion and say that the circles do touch. What were the options? They must be cutting. The circles touch or cut. Or will it neither touch nor cut? So it will touch or cut. Touch and cut, because they are cutting there at 2 points. All right, so that is question number 4. Then question number 5, the trigonometry. They want us to simplify this without a calculator. How long can it take for me to do this, and how much space do I need? So I know that tan negative is going to be the same as the negative tan x. The sine of 90 plus is going to give me the cos of x. Plus, I can expand this. It's an identity, which is 2 sine x cos x. I'm dividing it by 2 cos 36. 360 plus x is in the 4th quadrant, where cos is positive. So it's going to be 2 cos x. Then I go down and break this tan into sine and cos. It's going to be negative sine x over cos x. I'm multiplying by cos x. This 2 cancels that, this cos cancels that. I'm having just the sine x left. Now this cos is also going to cancel that, so that I have negative sine x plus a sine x. I'm getting a 0 as my answer. So mark allocation starts with just probably the reductions. 5.2. Given that the sine of 27 is predetermined without a calculator, each of the following. So let me just draw some bit of a sketch. Whenever I see such questions, I'll be required to have a sketch. This is a 27, that's a 90. This needs to be a 53. Does that make sense? Because I know, no, it's not 50, 63. It's a 63, so that I can have a 90 there. Okay, so they say the sine of 27, which is the opposite of a hypotenuse. Then I need to find this adjacent of mine, which must be 1 minus p squared under the root. All right, then let's answer this. Cos 27 is adjacent, which is going to be just 1 minus p squared. And then sine squared of 63. So I've flipped it around. I'm avoiding using the 90. So the sine of 63 is going to be the opposite over that. So it's going to be 1 minus p squared. And then everything is squared, which becomes 1 minus p squared. And then they want us to get the cos of 13,5. Let me just do this side. So cos of 13,5. We know that 13,5 is a half of 27. So if I take 27 to be my double angle, then 13,5 is going to be like the half angle, something of the sort. So if I use the double angle of cos, let me just use this. I'll have 2 cos squared theta minus 1. Okay. Then I'm gonna take this to be my theta. 27 is gonna be my 2 theta. So it's going to be cos 2 theta plus 1 over 2 under the square root, so that I get cos theta alone. So when I do the substitution, it's going to be cos 27 plus 1 over 2 under the square root. So we were told that the cos 27 is square root of 1 minus b squared. Okay, 1 minus b squared under the root sign. Yeah. We are adding a 1, then we're dividing by 2. So we can just leave it like that. We can leave it like that. This is the only approach that I'm seeing that I can use to obtain the cos theta alone. Okay, so that is 5.2. Then 5.3, we're given cos x plus sin x is k. Okay, cos x plus sin x is a k. What do they want us to simplify? Cos x minus 45. Okay, so just expand this using your compound angles. So that's going to be cos x cos 45 plus the sin x sin 45. I know that the cos of 45 is root 2 over 2, which is the same as 1 over root 2. So question never said without a calculator. So you can still use the calculator and still end up with the same thing. Okay, so take out the 1 over root 2. I'll have cos x plus sin x. We know that this is a k, so that's going to be k over root 2. Or you can have root 2 over 2 with a k. That's if you use the calculator straight away. Alright, so that is how that question would be done. Then 5.4, they want us to prove this identity. How do we prove this identity? So I can start from the left hand side because I'm seeing we have quite a lot of terms on the left hand side. Let me just jot it this side. It's cos 2 theta plus a 1 over sine 2 theta. Okay, then we are adding the tan theta. It must give us 1 over sine theta cos theta. Alright, so first things first, I need to break down the identities and see. So I know that cos 2 theta, I can break it down in terms of sine. So that's going to be 1 minus 2 sine squared theta plus a 1 over, this is going to be 2 sine theta cos theta plus, break that down, sine theta over cos theta. Sorry guys, we're starting from the left hand side. Okay, then you can simplify that or crisscross with the fractions. So that's going to be cos theta minus 2 sine squared theta cos theta plus a cos theta plus 2 sine squared theta cos theta over the 2 sine theta cos theta squared. Alternatively, you can find your LCM, which will be 2 sine theta cos theta. So when I look at this, now before I even go there, I'm seeing something simple for me to cross out. So this is going to cancel with this last part because they are identical but the signs are opposite. So which means I'm left with 2 cos theta on top over 2 sine theta cos squared theta. The 2 cancels the 2, 1 cos cancels 1 cos, and then I'm left with 1 over sine theta cos theta, which is the right hand side. So that's how that proof was done or was meant to be done. Then 5.5, determine the general solution. Okay, so on the left, it's just one trig ratio sine squared, which is fine. But on the right-hand side, I'm seeing a double angle there. And then a complementary angles as well. So I'm going to start by reducing that. So I have 4 sine squared theta is the same as sine 2 theta. Then I'm going to move everything to one side since I'm having one single trig ratio. So it's 4 sine squared theta minus, let me expand this to 2 sine theta cos theta is equal to 0. Then take out what is common, which is the 2 sine theta. I'll be left with sine theta minus, no. There's a 2 missing. So it's a 2 sine theta minus cos theta is equal to 0. Okay, so either 2 sine theta is a 0 or 2 sine theta minus cos theta is 0. So I'll just do that. Okay, so if I use the first approach, the reference angle that I have is going to be 0 and 180. So which means my theta is going to be 0 plus k times, so I'll just say k times 360. K is an element of integers. And then the other will be 180 plus k times 360. K is an element of integers. So these are the two solutions for the first part. Then with the second part, since I'm having sine and cos, I can create a tan. Okay, how do I create a tan? I'm going to divide both sides by 2 cos. Okay, over 2 cos. So this 2 cancels that, this cancels that. So I have the tan theta is equal to a half. And then my reference angle is going to be the shift tan over half, which is 26.57. Okay, tan is positive in quadrant 1 and in quadrant 3. So in quadrant number 1, just going to have 26.57 plus k times 180. Okay, I'm using 180 because the period of tan is 180. Then in quadrant number 3, I'll have 180 plus the 26. That's going to give me 206.57 plus k times 180. K is an element of integers. So that's how this question is answered. That's how I would approach it for 6 marks. All right, then question number 6, the trig graph. So in the diagram below, f of x is given as a sine bx, and then the g of x is for cos x. Within the interval of negative 180 and positive 180, the graph passes through these 2 points. And we have that they intersect at this point A and then B, blah, blah, blah. They want us to determine the value of A. So when you look at A, this A normally represents the amplitude of the graph. So F, we're seeing that it is reaching a maximum of 5 and it's reaching a minimum of negative 5. So automatically A becomes a 5. Because it's the amplitude. Then when you look at B, this B affects the period of the graph. Okay, so how many degrees do we have here regardless of the negative sign and the positive? So we have 180 degrees on the left, 180 on the right, which is a total of 360. And we can see that this is a full graph of sine. So within 360, which is the period of sine, we have one graph. So B is a 1. Alternatively, since you have your A as a 5, you can use the point 90 and 5. So that 5 is equal to 5 sine 90b. Divide both sides by 5, and then you have 90b. Then find the shift sine of 1, which is going to be 90. We have 90b. So still a B is your 1. Okay, so 6.2. The graph G, okay, the focus is shifted 30 units to the right and 2 units vertically down to form H. What is H? So H of x is going to be 4 cos of x. Since it's to the right, I'll subtract And since they are vertically down, I'll subtract also a 2. So that is how the equation should be written. Then 6.4, 1 mark. No, 6.3, 1 mark. Calculate the minimum value of 8 over g of x in the interval. Okay. So currently the minimum and maximum is 4 and negative 4. Now what if we have 8 divided by 4 cos of x? By 4, 8 divided by 4 gives us x, which is going to be 2 cos of x, which means the minimum value is going to be, is it a 2 or a negative 2? So I'm going to take it to be a 2, since I'm having the 2 there. So minimum value is a 2 for me. 6.4. If A is given as this, they want us to determine the coordinates of B. Now we're seeing that A is negative 141,34, which is in quadrant number 3. So if I plus 180 with that, negative 141,34 plus 180, I'm getting 38,66, which must be this is in between 30 and 60. Okay, so 38,66. Y values just have to be the same. This is negative 3,12, then that has to be a positive 3,12. Then 6.5, for which values of k will this have no real solutions? Okay. Now for the graph of f to have no real solutions, it shouldn't touch the x-axis. Now since the minimum is negative 5, if we choose to increase this graph or to shift it 5 units upwards, okay, it will be now touching one point there, and we won't have any other point between this interval. Okay, so we either need to shift it more than 5 units upwards, or we need to drop it more than 5 units downwards. So I'm going to say that k has to be greater than what? Than 5 units, or k must be less than 5 units. Am I contradicting myself? Does that make sense? That k has to be greater than 5. Okay, so if that is true, which means we are shifting it more units upwards. Now let me just call it negative 5. Yeah. Okay, then 6.6, use the graph to determine values of x in the interval for which f is less than g. So where do we find the graph of f to be below g? From this point up to this point, that's where f is below. Okay, so I'm going to say negative 141,34 is less x and is less 38,66. And then where do we find f prime? So we know that f prime simply represents the gradient. So we want the gradient of f to be either increasing as the graph is also above the x, or we want the gradient to be decreasing as the graph is also below. So that scenario can only be seen if I do this graph is above as this one is below. Okay, so I don't know which scenario. Oh, we're talking about gradient, by the way, gradient. So let me look at the first scenario. Where do we find the gradient to be increasing? Well, this one is above the x-axis. G, where is G above the x-axis? Between this and this. It's okay, I can still use this point as well. Okay, so F is increasing between this point, and G is above between still this point and this point. G is going to be above between the negative 90 and the positive 90, and F is also increasing. So I'm going to say negative 90, first of all, is less or equal to X is less or equal to a positive 90. Then, where do I find the other scenario? The graph to be decreasing as G is below. So G is below after 90. Okay. And this graph is decreasing also. Okay. So this one is decreasing, and this is also below. So even this one, negative 180 to 90. So negative 180 less or equal to X, less or equal to negative 90. Also 90 is less or equal to X, less or equal to 180. So in other words, the whole domain satisfies this whole thing. All right, then question number 7. The diagram below TQR represents 3 points in the horizontal plane. Okay, with the vertical blackboard. The angle of elevation of the top of the pole from R is theta. Okay, TQTR is Y, TQR is X, and that is alpha. Express theta in terms of alpha, show that that is that. So what I can see is that if this is a Y, this one is also a Y, which means this entire angle here is also going to be alpha. So I have alpha plus theta must give us 180. So theta is going to be alpha minus, no, theta is going to be 180 minus 2 alpha. Now if I introduce sine on both sides, I will have sine theta is equal to the sine of 180 minus 2 alpha. When I reduce this, it's going to give me sine 2 alpha. So that is the same as that. So that's what they wanted. So this is the first statement that they wanted, because we are expressing theta in terms of alpha. And then we are showing that by introducing the sign on either sides. Then 7.2. Hence, so from what we just obtained, can we proceed and prove that PR is that? This PR? PR is this hypotenuse of this triangle. So I can use what we call this. Let me use the cosine ratio and say the cos of theta using this triangle PQR. It's gonna be X over PR. Make PR the subject, X over cos of theta. But this expression does not have any X involved. So what I'm going to do, I'll go back to this triangle of ours and use the sine rule and see Y over the sine of alpha is the same as X over the sine of theta. And then I'll make X the subject, which is going to be Y sine theta over sine alpha. But we say that sine theta is the same as sine 2 alpha. So which means it's going to be Y sine 2 alpha over sine alpha. And then simplify this by expanding that double angle. So that's going to be Y, let me just say Y times 2 sine alpha cos alpha over the sine of alpha. So this cancels that. So which means my X is 2Y cos alpha. And then just substitute that on top where there is P. So So in the PR. So PR is going to be 2y cos alpha divided by the cos theta. I think that's what they have. Perfect. Then 7.3, if that is that and that, calculate the area of TQR. TQR. So we can just use the area rule. Which angle do I have? I have alpha. So I'm going to say area is going to be a half times TQ multiplied by QR, and then the sine of alpha. So a half, my TQ is Y, which is 15. My QR is X, which is a 20. And then the sine of 49. Okay, so when I punch this into my calculator, it's a half multiplied by 15 multiplied by 20 sine of 49. Getting 113,21. This is going to be units squared. So that is 7.3. Then 7, that's the end of question 7. Question 8, Euclidean. Diagram below, in the diagram below, O is the center, beautiful. A, B, D are points on the circle, BC is a tangent, okay. And DBC is a 22,5, okay. The chord AD, where are you AD? Here I am. Is produced such that these two sides are equal. Okay. 8.1, they want us to get the size of A1. So A1 is going to be 22,5. Reason, that's going to be the tan chord theorem, because this is a tangent, and then we're seeing that this is a chord. Angle in between the tangent chord and blah, blah, blah. So if this is a 22,5, they want us to get D1. So for you to get D1, you can start by telling us that C. Okay. C is also 22,5. Angles opposite, equal sides. Okay. Which means that D1 is going to be a 45. That's going to be exterior angle of triangle BCD. We're saying this is a 22,5, but this D1 is an exterior, which must be a sum of these two. Okay, that's a 45. Then they want us to get B2. So when I see this is a radius, okay, so if that's a radius, it simply means that the tangent and the radius must be perpendicular to each other. So this B2 and this 22,5 should be complementary angles, or they are complementary angles. So what is 90 minus 22,5? What do we get? 90 minus 22,5, I'm getting a 67,5 on my calculator. Okay, so that's going to be 67,5. Reason, the tan perpendicular to the radius. Okay, so this is 67,5, the small one. Then they want us to get O1. This is an angle at the center, O1. But D1 is at the circumference. So the angle at the center is always 2 times. So O1 is going to be 90. Angle at the center must be twice angle at the circumference. All right, then 8.2. 8.2. Can we prove that OA is parallel to CB? OA is parallel to CB. Now, when you're proving parallel lines, you just have to deal with the properties of parallel lines. That's the alternate, corresponding, and co-interior. Okay. So we've seen that this is a 90 from the previous statement that we wrote. But we know that even this whole B is a 90. So we can see that these two angles are alternate. So you're going to say that CBO is the same as BOA. We've proved from above. Therefore, OA is parallel to CB. Reason, the converse of alternate angles. The converse of alternate angles. Okay, then 8.3, it's further given that the radius is 12. The radius is 12. Okay, this is a 12. This is also a 12, but we know that this is 90. They want us to get the length of BC. BC. All right, so before we even go, anyway, let's do this. As I thought, let me get BA first. Okay, using the Pythagoras. So that's going to be square root of 12 squared plus another 12 squared, which gives me 12 root 2. That's what I'm getting, right? 12 squared plus 12 squared, getting 12 root 2. Okay? So use the Pythagoras. Then we can, you can write the Pythagoras theorem and tell us that the AB is going to be the square root of OB squared plus the OA squared. It's fine, then Pythagoras, then do that. Then what I'm seeing is that CB is the same as AB, because if this is a 22,5, even this is a 22,5. Okay, so we can come down and say that since A1 is the same as C, which is 22,5, it simply means that AB must be the same as BC, because those are going to be sides that are opposite equal angles. Therefore, our BC is also going to be 12 root 2, or you can write it as a decimal to be 16,97 units. Okay, then question number 9. The diagram below, we have a diameter BE of the circle O is produced to D. DA is a tangent to the circle, and CD is perpendicular to BA. AC and BC cut the circuit E and F. Beautiful. OF and EF are drawn. Okay. Just 3 parts. Okay. You can do this. 9.1. They want us to prove reasons why ABCD is a cyclic chord. I'm seeing a 90 here, and I'm seeing some bow tie, butterfly. So I'm going to say that A2 is a 90-degree angle in a semicircle, because this is a diameter, so this must be 90. And now the bow tie is matching, because I'm seeing a 90 and I'm seeing a 90. So go down and tell us that since A2 is the same as D2, therefore ABCD is a cyclic chord. And the reason is going to be the converse of angles in the same segment or angles subtended by the same chord. Angles in the same segment or angles subtended by the same chord. So that is 9.1. 9.2, we need to give reasons why AD bisects this angle B, ABC. So which means this angle must be the same as this angle, according to the statement. but what's going to be the reason? How do we get there? So I can start by saying that since I've proved that this is a cyclic quad, which means there is some sort of a circle somewhere, it simply means that this angle A3 is going to be the same as B2 because of the bow tie. Angles in the same segment, or angles subtended by the same arc. If that is true, I'm also seeing that A3 is the same as B1. That is the tan chord theorem, because this is a tangent and then this is a chord. It must be the same as that. So since A3 is B2, A3 is B1, therefore B1 is the same as B2, hence BD bisects ABC. Okay, that is that. And then lastly, can we prove there with reasons that EC is a tangent to the circle OEF? So if we draw a circle here, they want us to prove that EC is a tangent. Now, it's going to be a bit tough for me to prove from this perspective of E3. But rather what I'm going to do, since I know that EC is the same line as AEC, let me take it from this approach and focus on E1. So I need to prove that E1 is the same as F2. Then I use the tan chord. If that is true, then EC is a tangent. Okay, so what we do? So what I'm going to start by saying that we know that F2 is the same as E2. Angles opposite, equal sides. Okay, because this is a radius, this is also a radius to the circle. So this angle is the same as that. Then if that is true, we were told about the 90 and the bisections. Let me look for E2. Let me use this triangle BEF and find B2. So since this is a 90 also, F1 and 2 is a 90 angle in a semicircle. F1 plus F2 is a 90 angle in a semicircle. Or you can tell us opposite angles of a cyclic quad, which means that E2 is going to be 90 minus B1. Is it B1 or B2? It's going to be B2, but we say B2 is the same as B1. Okay. Then I can also find E1. E1 is also going to be a 90 minus a B1. This will be angles in a triangle, or angle sum of a triangle. Now, since initially we say that this angle here, the 90 minus B1, is the same as this one, 90 minus B1. And now we found this to also be 90 minus B1. So there is a tan chord kind of correlation. And therefore, I'll say AEC is a tangent, okay, because of the converse of the tan chord. Question wanted EC. So there's no point of putting AEC. But since it's the same line, so this is still continuous. Okay, so that is question number 9. Number 10. Question number 10. They want us to prove the proportionality theorem with similar triangles. Okay, so what I'm going to do, since we've already been given that the lines are parallel and all of that, I'll start by saying that B is the same as ADE. Those are corresponding angles because DE is parallel to BC. Then I'm saying C is the same as AED. Okay, it's the same reason, corresponding angles, because DE is parallel to BC. Then we can see that the angle A is common. Okay, A is common. Therefore, or which implies that ADE is similar to ABC because of the angles. Okay, now there's a link between similar triangles and then the proportionality theorem. Okay, so if I focus on the similar triangles first, since I've proved that the triangles are similar, it's the same as me having AD, okay, divided by AB, which must give me the same ratio as AE divided by AC, which must give us the same ratio as DE divided by BC. Okay, then I can go down and say that using the proportionality theorem of similar triangles, or with similar triangles, then I can just draw the conclusion and say that my AD over DB should be the same as AE over EC. There we go. That's 10.1. And then 10.2 is the application. So in the diagram below, D is the center of the circle. A, B, and AE are tangents. Okay, so these tangents are coming from a common point, which is A. So one thing I know is that the two tangents must be equal. Then at B and then at E, respectively, the diameter BG, okay, is produced to meet tangent at E, so at C. DG is the same as that. They have indicated that for us. And then these lines are parallel. All right. Find with reasons the ratio of AC over FC. AC over FC. So from the proportionality theorem, we know that if we have our AC over FC, why am I writing it side? Let me just do it this side. Okay, so AC over FC is going to be the same as BC over CD. Now, we know that this is a radius. Let me just call it R or X or any letter. Let me just call it R. So if this is R, this is also R, but this is the same as that, which is also R. So which means my BC is going to be 3 times of R, which means it's 3R, over the CD. CD is twice of R. The R's will cancel, which means the ratio is 3 over 2. Then can we prove with reasons why ABC, the big triangle, is similar to DEC? So number one, we can say that B, this angle, is going to be the same as B1. B is the same as E1, which is 90. The reason is going to be the tangent must always be perpendicular to the radius. Okay, that is statement number one. Then we can also see that are they? Which angles are they? So this is a 90 and a 90. A, B, C. Okay, C is common to both of them, which means that D3 must be the same as A. And the reason is the remaining angles of the triangle. So therefore, ABC is similar to DEC. Reason is angle, angle, and angle. So remember what we say, C is common to both triangles, the small one and the big one. Then E1 is the same as B, which is a 90 turn radius, then automatically that must be the remaining triangles. Okay, then if that is true, then we need to prove that DE squared is the same as this. Okay, let me see what I'm going to do. So if I'm to sketch my two triangles, anyhow, calling this A, B, and C, and then I have the triangle, we said A is going with a D3, B is going with E1, and then C is common. Then let me apply my ratios for the similar triangles. So what I can see is that if I need a side that is having DE or ED, which is this. So I'll say AB over DE. Which other side? We have EC, which means I need to use this side. BC over CE. Okay. I'm gonna tell us that from similar triangles, or you tell us that this triangle is similar to that. Someone is asking for the reason on the 10.2.1. It's gonna be the proportionality theorem, guys, because FD is parallel to AB. Okay, no, it's fine. Let's move on. So if I do this, remember my interest is a DE. I can make DE the subject, which is going to be AB times the CE over EC. I cross multiply. But from the statement that we were given, we only have the EC and we have one DE there. The rest of the terms are not there. So let's play around and see. Okay. AB. Let's see what is our AB. We're seeing that our AB is the tangent, a common point, which is the same as this. So we can say that AB is the same as AE. Okay. So AB is the same as AE. We say tangents from a common point. So where there is AB, I can just replace it with A. Problem sorted. Now problem is gonna be let me do that. So AE multiplied by CE over BC. Okay, then how does BC relate with DE? Maybe I can get another DE from there. Okay, so I can see that DE is a radius. But BC. BC is 3 times of the radius. So since this is R, I'm just gonna say that BC is 3 times of ED from that information. So that's gonna be DE is equal to AE multiplied by CE over 3DE. Multiply both sides by DE. So times DE multiplied by DE. So this cancels that, which means DE squared is the same as AE multiplied by CE over 3. Okay, so that is 10.2.3. Then 10.2.4. They want us to get the ratio of the area. Don't have space, but I'll squeeze it here. Okay, so our focus is area of FDC. FDC. So since this line makes 90 degrees, so it's perpendicular to this line, so I'm gonna take this to be my base for both triangles, since I need ABC and FDC. So I'll say it's a half multiplied by the base, which is gonna be now FC, multiplied by the height, which is ED, divided by a half. I'm still gonna take AC to be my base, which is AC, multiplied by the height, which is still the same height, which is ED. So what I can see is that the heights are cancelling. The ED and the ED are cancelling. The half and a half is cancelling. I'm left with FC over AC. Originally in 10.2.1, I had the ratio of AC over FC. Now I'm flipping it around. So the ratio is just going to be 2/3. So guys, that's what was expected of this paper. And I wish you all the best, and I hope we got most of the marks. All right, for me, I'll stop there and I'll sign out till we meet again. Bye-bye.